Hi AP Calculus students. Welcome to AP Calculus 2.5. You know what? I'm going to throw an A on there because there's going to be a B. This is called implicit differentiation. I abbreviated ID so I don't have to keep writing it. This is where we will be finding the derivative of an expression that's in terms of x and y. That's called implicit. Instead of just x, that's called explicit. This is what we have been doing. We just haven't called it that because we were just doing this one thing, so we didn't need to name it. So, number one, basically here's what's going on. In one statement, how do I find a derivative using implicit differentiation? Here's what you do. When you take the derivative of a term with only x's, you simply take the derivative. When you take the derivative of a term with only y's in it, for instance, right here, when I take the derivative of y squared, you take the derivative, as you always would, using your y's, and then you multiply by y prime. You multiply by the derivative of y. So if you want, I got a lot going on here, but if you want a nice easy rule, that's what you do. You take the derivative of something with x's, just take the derivative. Take the derivative of something with y's, take the derivative, multiply by the derivative of y. Number two, why do we need implicit differentiation? Because many expressions that may or may not be functions are written best in terms of x and y, not just x. For instance, here's how we write the equation of a circle, x squared plus y squared equals 9. Notice that it's a lot easier to write this circle in these terms. If I got the y alone in terms of x, I've got my square roots, plus and minuses, you've seen that. This expression right here in terms of x and y, this is actually a rotated ellipse that looks like this. So take a look at this circle and this ellipse, and I put tangent lines on it. Shouldn't we be able to find these derivatives and these tangent lines? Yes, we should, and we use implicit differentiation to do that. So 3, from number 1, why do we multiply by the derivative of y? Notice I underlined it in blue. Because in the past, we've always taken the derivative with respect to x. By the way, that's this symbol here, the derivative with respect to x. Because we only had x's, nothing else. Now when we take the derivative with respect to x, but our term has a y composed in it, notice I said composed, so we're talking a chain rule. We take the derivative with respect to x, then by the chain rule, we multiply by the derivative of y, the inside function, which is y prime. Okay, so for instance, when we come over here, when I take the derivative of x squared, 2x, because it's with respect to x, when I take the derivative of y squared, it will be 2y times the derivative of y, because there is a y composed in my x function, so I have to multiply by the derivative of the inside function. Okay, so let's take a look. Oh, number 4 are the examples we're going to do. Okay, in green, here's the steps we do. How do we perform implicit differentiation, meaning we're finding the derivative of y? A, take the derivative of both sides of the expression with respect to x. Left to right, perform the differentiation. Simply take the derivative of the x terms. If taking a derivative of a y term, take the derivative and multiply by y prime. Use your power, product, quotient, and chain rules carefully. You know what those are. C, collect all terms with a y prime on one side of the equation and all the terms without a y prime on the opposite side of the equation. Factor out your y prime, divide, simplify. Whew, sounds easy, doesn't it? Here we go. So, given x squared plus y squared equals 25, you know what this is. It's a circle with a radius of 5, with a center of 0, 0. Find y prime. So here we go. We are going to take the derivative of both sides with respect to x. Now I'm going to go left to right. The derivative of x squared with respect to x is 2x, plus the derivative of y squared is 2y times the derivative of y equals The derivative of 20, I didn't say it right, the derivative of 25 with respect to x is 0. The next thing you do, keep all your terms with y prime on one side, get all your terms without y primes to the other side. I'm going to subtract a 2x from both sides. And now I am going to get my y prime alone by dividing by 2y. And I get that the derivative of y, which was what I was shooting for, is a negative x over y. What does this mean? I just wanted to show you, I drew a picture here. Notice that the points 3, 4, 4, 3, and all these points are on this circle with radius 5. Let's take a look. That means at the point 3, 4, that the derivative of the slope of the tangent line I drew would be negative 3/4. Sure enough, looks like it could be. That means at the point 4, 3, right, that the slope of that tangent line would be negative 4/3. And certainly it is negative and looks steeper than the 3/4 we just found. Let's just check this one over here. The slope of this tangent line, or the derivative at this point, at the point 3, negative 4, when I put in a 3 here and a negative 4 here, I get 3/4. Notice that is a small positive slope. So that really does work. The next problem we're going to do is number 6. Let me get this copied. Number 6. They are asking you, they say find dy dx. That is called y prime. And that is x squared times y plus y squared times x equals negative 2. Okay, here's where you have to be careful, class. I'm going to take the derivative of both sides with respect to x. Okay, notice that I have a product rule here and a product rule here. Okay, let's do this product rule first. I'm going to talk my way through it. Here we go. The derivative of x squared is 2x. I'm going to keep my y, plus I keep my x squared and multiply by the derivative of y, which is 1, times y prime. Okay, product rule here, plus product rule here. Take the derivative of y squared with respect to x, that's 2y times y prime. I keep my x, plus I keep my y squared and multiply by the derivative of x, which is 1, and the derivative of negative 2 is 0. The next thing I do, I'm going to keep my terms with y prime on the left and get my terms without y prime to the right. So here we go. Keeping x squared times y prime and 2y times y prime. See this x right here? I'm going to move it in alphabetical order. So you know what? I'm going to rewrite this. Okay. Kept my x squared times y prime here. Right here, perfectly acceptable. I like my things in order. I'm going to call this 2xy. I always like my y prime at the end. Okay, equals, I am going to subtract the 2xy, and I'm going to subtract the y squared. Now, why did I do this? Why do I like just terms with y prime on one side? Because I'm trying to solve for y prime, and now I can factor it. It is in common in both these terms. It's not in common here, so I had to get rid of them. Now there's a y prime in common. I will write what's left. I'm just rewriting the right side of the equation. And now, to get y prime alone, I will divide by x squared plus 2xy. There we go. And our y prime is equal to this very interesting expression here. Okay. Next. I think I have number 14. Same question. They're asking for the derivative of y with respect to x, or y prime. And number 14, I was sure to have a little trig in here. Here we go. Let's take the derivative of both sides with respect to x. Okay. The derivative of cotangent is a negative cosecant squared y. Let me think about that a minute. Is that true? The derivative of tangent is secant squared. Yep, got it. Times y prime equals the derivative of x is 1 minus the derivative of y is 1 times y prime. Okay, take a look here. I have to have all my y primes on one side of the equation, so I'm going to add a y prime to both sides. I have y prime minus cosecant squared y times y prime. I just have a 1 on the right. Now I can factor the y prime because all the terms have a y prime in common. That is 1 minus cosecant squared y equals 1. Now to get y prime alone, the derivative of y, I will divide by 1 minus cosecant squared y. 1 minus cosecant squared y. Let's cross that out. That is our y prime. You know what though? Let me think about it. I am betting this is absolutely correct, but I'm betting if I look in the back of the book, it doesn't look like this. I think I'm seeing a Pythagorean identity right here, right? A 1 and a trig function being squared. Let me write that Pythagorean identity and let's see if that's true. Let's see. That's cotangent squared plus 1 equals cosecant squared, right? So let's see. If I subtract a 1 from both sides, there we go. That's true also. But I have a 1 minus. Okay, so if I go through and multiply everything by a negative, there we go. I think this expression right here, that's 1 minus cosecant squared, is actually equal to a negative cotangent squared. Okay, if it's okay with you, I'm going to move the negative up to the numerator. And take a look here. Isn't the reciprocal of cotangent, isn't that tangent? So isn't this really, why have a cotangent in the denominator? Why wouldn't we say, well, the reciprocal of cotangent is tangent, so the reciprocal of cotangent squared must be a negative tangent squared. Oops, we have y's, don't we? There we go. I am betting that's what it says in the back of the book. We were good way back here, but I'm betting that they simplified it to look like this. Okay, let's go, our last one, number 30. Let's see what kind of horrors they can wreak on us now. There is a picture on number 30, but we really don't need it. They're asking for the slope of the tangent line. Slope of tangent line. That's a derivative, right? They give a picture, but they give the equation with it. This is called a cissoid. Got some cool pictures in here. And they are asking for the tangent line at the point 2, 2. Let me make sure I wrote that right. I did. Okay, let's take the derivative of both sides with respect to x. Okay, product rule right here. Going to talk my way through it. Going to take the derivative of 4 minus x, which is a negative 1. Going to keep my y squared, plus going to keep my 4 minus x squared, and multiply it by the derivative of y squared, which is 2y times y prime. The derivative of x cubed is 3x squared. Now, at this point, you're tempted to, keep the y primes on the left, get everything else to the right, and solve for y prime, and then pop in the point 2, 2. You know what's the best thing to do is when you have been given a point, use it right away. My x is 2 and my y is 2. Let's put that in. So right here, wherever I see a y, I'm going to put a 2. Wherever I see an x, I'm going to put a 2. And that will be much easier to solve for y prime. Here's my negative 1. 2 squared is 4, plus 4 minus 2 is 2, times 2, here's another y times 2, times y prime equals, when we put a 2 in here, that's 4, 3, we're going to get a 12. Let's take a look. We have a negative 4 plus 2 times 2 times 2 is 8y prime equals 12. Add a 4 to both sides equals 16, right? And divide by 8. There we go. Y prime equals 2. So on the cissoid that they show at the point 2, 2, that tangent line would have a slope of 2. Notice if I was working to get the y prime alone and then put the point in, I'd probably still be working. But I'm done. Thank you so much for hanging out with me today. Have a good day.
Enjoy.